Hello everyone, welcome to my presentation. My name is Wei Zhao, and I'm from the School of Computing and Information Systems at the University of Melbourne. Today I'm going to present a critical overview of current practices of ubiquitous music making systems. Ubiquitous music, or Ubimus in short, is ubiquitous systems of human agents and material resources that afford musical activities through creativity support tools, according to Keller and colleagues. The concept of ubiquitous computing can be traced back to 1999, when Weiser proposed that ubiquitous means systems that allow computing to take place anytime and anywhere so that they can be weaved into the fabric of everyday life. There are many similar concepts, such as networked music, augmented instrument, and Internet of Musical Things. According to the literature, there are a couple of features of ubiquitous music making systems. It is not limited to specific venues, which means they can be applied in everyday settings. Users can use tools that might not be designed for musical purposes originally. The interaction is not limited to users' input and devices' output, which means there might be other contextual factors affecting the interaction, such as the venue of using. While these features can provide great opportunities for creativity, it can also pose great challenges because of the complexity it involves. This paper aimed to explore the developments of ubiquitous music-making systems through a review of the literature, and it further aimed to uncover the challenges and limitations of existing systems and areas that need future improvements. Turchett and colleagues presented a system called Sensus Smart Guitar in 2016. As can be seen from the figure, the interaction in the system is not limited to musicians and audience. The instruments musicians are playing are connected wirelessly with smart devices the audience have, so that the audience can influence the music-making progress. This example shows how ubiquitous music-making systems can engage audience into the music creation process and improve the interactions, but it also raises the concerns that involving too many computing components might turn music performances into demonstrations of computing powers. It reminds us that music creators should always possess the dominating role in the creation process, and computing components should not affect their creative expressions. Another project that supports everyday creativity is called Sibilum. The system consists of a smartphone placed on a resonance box mix of cardboard, with push buttons that can be interacted by the smartphone through a video camera. This project can be applied in the field of music education to assist users in learning harmony perception and melody sight reading. It provides a low-cost solution for music making that can be implemented anywhere and shows the possibility of using ubiquitous music systems for educational purposes. But it is supposed to be used individually, and it does not support collaborative music making. Carson designed a participatory music-making tool called Mesh Garden, which allows a group of people to create music through networked smartphone speakers. The participants can control the music-making process by altering the orientations of their phones. It has high level of accessibility since it only needs a smartphone to start. From this case, we can see that resources for ubiquitous music systems are distributed in everyday settings. Therefore, social interactions between users can encourage exchange of resources and thus stimulate imagination and creativity. The last case I would like to present is the application of ubiquitous music making into art installations. The Memory Tree project involved a tree with playback devices that play excerpts recorded by remote users and shared through social network tools. It supports not only local forms of social interaction, but also integrated social interaction from remote physical locations. This example can also demonstrate the flexibility of ubiquitous music systems. As presented in the above sections, ubiquitous music-making systems normally include features including mobility, context awareness, everyday creativity, and network connectivity. While these features can support creativity, they can pose a variety of challenges to the deployment and application of ubiquitous music-making systems. The first one is about interoperability and standardization. This is because of the varied communication technologies used in the components, especially when non-musical components are included. The second issue is about sustainability. The rapid update cycle of mobile devices requires the system to have an API that can adapt to the updates quickly. The third issue is about privacy and security. This is a common issue for ubiquitous computing systems, but for music systems particularly, it involves the protection of copyright, which requires high level of data encryption. According to the literature, when designers try to include cognitive or emotional components into the music-making systems, it is difficult to find meaningful patterns from it, which is an area that deserves future attention. Finally, regarding research methodology, we found a lack of studies on the context of use and music creators' actual needs, and thus we suggest more ethnographic work with system users and evolve them into the design of newer systems. More details can be viewed from the paper once it's been published. Thanks for your attention.